All right, so these are the 3-5 notes. You should have the note packet and your homework. You should also have your textbook open to section 3-5 or page 187 in your textbooks. We're going to be talking about arithmetic sequences as linear functions. We've been talking about linear functions for this entire chapter, and basically that means if I graph a function, I get a line, and I can write it in standard form. A sequence is something like 1, 2, 3, 4, 5, 6, or 2, 4, 6, 8, 10, things that change the same amount in between each term. Each piece of a sequence is called a term. So we're going to start with our definitions. A sequence is a set of numbers, which we know are the terms, in specific order. A set of numbers in a specific order. Terms of a sequence are the numbers in the sequence. So if we have 2, 4, 6, 8, 2 is a term, 4 is a term, 6 is a term, 8 is a term. All right, an arithmetic sequence is a sequence that has a common difference between each successive term. So in between 2, 4, 6, and 8, it changes 2 each time. 2 to 4 is plus 2. 4 to 6 is plus 2. 6 to 8 is plus 2. And they're being added or subtracted. Arithmetic means adding, okay? So an arithmetic sequence is a sequence with a constant difference between successive terms. Successive is just like consecutive, where they're one right after another. Okay, the common difference is the difference between the terms. Of a sequence. And for today, we're going to call it D. For difference. All right, so here are some examples. Remember that the 3 dots at the end of the sequences are called ellipses, and they indicate that the pattern keeps going. Arithmetic sequences are infinite. They keep going until infinity, but we don't have enough room on a piece of paper to write that down, or nor do we want to. So we indicate that it keeps going by those 3 dots. So, for this example, 3, 5, 7, 9, 11, ... we're going to start talking about the common difference. To get from 3 to 5, it's plus 2. From 5 to 7, plus 2. 7 to 9, plus 2. 9 to 11, plus 2. So, D is positive 2 because you're adding it. For this example, I'm going from 33 to 29. And so to get from 33 to 29, I subtract 4. From 29 to 25, minus 4. 25 to 21, minus 4. 21 to 17 is minus 4 as well. So the common difference there is negative 4, because I would add the negative 4 to each term to get the next one. All right, turn the page. You should also turn the page in your textbook. All right, so maybe they're going to give us a set of integers and they say, is this a sequence? So the thing you can do is find out if it has a common difference between each term. If it does, list the common difference. So from 4 to negative 2 is plus 2. From negative 2 to 0, plus 2. From 0 to 2, plus 2. D equals 2 because it's the same in between each term, so yes, this is a sequence. Let's put in it's an arithmetic sequence. That's what it's asking for specifically. Okay, now for the next one, we're dealing with fractions. We know how to deal with fractions. Let's rewrite them with common denominators. I see that my biggest one right now is 16, so that's what I'm going to go for. So to rewrite 1/2 with a denominator of 16, I multiply the top and the bottom by 8. So I get 8 over 16, comma, to get from 8 to 16, I multiply the top and bottom by 2. So now I get 10 over 16. To get from 4 to 16, I multiply by 4. So I get 12 over 16. And then I already have 13 over 16 with a denominator of 16. Okay, now we can start comparing them. To get from 8/16 to 10/16, I add 2/16. To get from 10/16 to 12/16, I add 2/16 again. To get from 12/16 to 13/16, I only add 1/16. So even though these two were the same, this one is not. So because they don't have the same one, they don't have a common difference, and thus they are not an arithmetic sequence. All right. Now, we know how to determine if things are sequences or not, but now we have to decide what are the continuing terms or what comes after the ... So the first thing you have to do there is find the common difference. So from 15 to 9, I subtract 6. From 9 to 3, I subtract 6. From 3 to -3, I subtract 6. So these are the same. This is an arithmetic sequence, and now I know my common difference. D equals -6. So to find the next three terms, I just start working from where it left off. So I'm going to say -3 minus 6 is -9. -9 minus 6 is -15. -15 minus 6 is -21. Now I have the next three terms in my sequence. All right, let's do the next one. So to get from 9.5 to 11, I add 1.5. From 11 to 12.5, add 1.5. 12.5 to 14, add 1.5. These are all the same. Their common difference is the same. So we know that D equals 1.5. To find the next three terms, I pick up my last term and start adding. I have 14.0 plus 1.5. That gives me 15.5. 15.5 plus 1.5 gives me 17. That's my second term. Then I have 17 plus 1.5, and that gives me 18.5. Now I have the next three terms, 15.5, 17, 18.5. All right, turn the page. We're going to start talking about the algebra side of sequences. You should be on page 188 of your textbook, and if you look at the bottom half, right above that key concept, there is a little table. We're going to be making that table in our notes, so pay close attention. So we can start representing them by talking about their first term and their common difference. You always have to be concerned about the first term because if we look at the example, look in your textbook on example 2. Do you see how they start at 15? That might be the very first term in that sequence, and there might not be a number to the left of it. So we have to be considerate of that first term and its common difference. So for algebra, we're going to do this in columns. We're going to deal with our symbols first, terms of A1 and D, and then we'll deal with the numbers. So the first term, you call it A sub 1, and all that means is the first term. Okay, so the second term would be A sub 2, 2 for second. A sub 3, 3 for third. A sub 4, 4 for fourth. Now when we come down to the nth term, we don't know what that number is. the nth term is whatever number we decide. It could be 100, it could be 200, it could be 1 million. We don't know. So we write it in terms of algebra. We say a sub n. Now, we know that once we have the first term, to get to the second term, we have to add in the common difference. So to get from a sub 1 to a sub 2, I have to add d. So I'm going to say a sub 1 plus d. Now remember, if there's no coefficient in front of our variable d, we're going to say it's 1. But I don't know what a sub 2 is yet because I don't know my common difference. We're just talking general terms with variables in algebra. So if I come down here, I would say a sub 2, which we know is a sub 1 plus d, plus another d, because to get from here to here, I have to add in that d again, which is the same thing as a sub 1 plus 2d. So what do you think is going to happen for the fourth term? We should be getting something like a sub 1 plus 3d, because I add another d to the third term to get my fourth term. Something you should notice is the coefficient in front of d is 1 less than the term number. So for here we have 1d for the second term. 1 is 1 less than 2. Now we have 2d. 2 is 1 less than 3. Now down here we have 3d. 3 is 1 less than 4. So if we come down to the nth term, we know we're still going to have a sub 1, and we're going to add in a certain number of d's. But since we don't know what n is, we're going to write it as n minus 1 times d. The n minus 1 is because it's 1 less than the term you're on. 3 was 1 less than 4. N minus 1 is 1 less than n. That's our general equation for arithmetic sequences. So if we're dealing with numbers, I'm going to say that d equals, let's see, in our textbook it uses 3. I should have listed that on your notes. Go ahead and write that in. They're going to say our first term, so a sub 1 equals 8, and d is 3. So to find my second term, I say a sub 1 plus 1 times d, which is 3, which is 8 plus 3, or 11. Now down here for the third term, I say 8 plus 2 times d. So 8 plus 6 equals 14. A sub 1, which is 8, plus 3 times 3, so 8 plus 9 equals 17. Now, let's take a look at our sequence. We have 8, 11, 14, 17. Does it increase by 3 each time? 8 to 11 is 3, 11 to 14 is 3, 14 to 17 is 3. So yeah, that works. So now let's see what we would have to write for the nth term of this sequence. I'm going to say 8, that's my a sub 1, plus, I don't know what n is, so I still say n minus 1 times 3. Okay? That's where I leave it. The nth term of an arithmetic sequence with the first term a sub 1 and the common difference d is given by the equation a sub n equals a sub 1 plus n minus 1d. We just wrote that down, where n is a positive integer. You can't have the negative 16th term of an arithmetic sequence, so that's why they add in that positive integer. All right, turn the page. So they're saying we have a sequence. Let's find out what the original equation of this sequence is. So I know, let's write down the equation that we just wrote down. We know that it is a sub 1 plus n minus 1 times d. We know the very first term is negative 12. Now we have to find the common difference. So from negative 12 to negative 8, I add 4. From negative 8 to negative 4, I add 4. From negative 4 to 0 is add 4. So d equals 4. So I'm going to say negative 12 plus n minus 1 times 4. I know how to simplify this even further. Remember, simplified means no like terms and no parentheses. So to do this, I'm going to have to distribute this 4, and since it's next to n minus 1, I distribute it to n and to minus 1. So I have negative 12 plus 4 times n is 4n minus 4. Okay, minus 1 times 4 is minus 4. Now I have these like terms, negative 12 and negative 4 are like terms. So if I have negative 12 minus 4, I get negative 16 plus 4n. I'm going to rewrite that so I don't have a negative 16. I want the n term to come first. And I'm going to use the commutative property to rewrite this, which means that I'm going to move 4n out front. It's positive because it's being added, and then minus 16. It's being subtracted because it's negative as the first term up here. This is the general equation for this arithmetic sequence. So what if it tells me find the 24th term? Now, I could go through and add 4, use the old school method of adding 4 24 times to make sure I get to the right answer. Or I could just plug in 24 for n up here because I know that n is 24 here. Now, if we're using smaller numbers like, what if we wanted to find the 9th term? It might just be easier to just add 4. But what if they wanted us to find the 342nd term? I'm not going to add 4 342 times to find the answer. I'm just going to plug in the n that I want. So I'm going to say 4 times 24 minus 16. 4 times 24 is 96 minus 16 equals 80. So the 24th term of this sequence is 80. And I'm going to write a sub 24 because that is my a sub n. All right, turn the page. Now, if I were to go through and graph these, I would have a graph that looks kind of like this. I'm going to scoot this down. I would have my y-axis, and I'd have my x-axis, my origin. Now, I'm not going to have x values or y values because I'm not talking about x and y. I'm talking about n and a sub n and all those things. So we're going to say that the x-axis is a sub n, and then the number in the sequence is my y value. So like back here, my a sub n was a sub 24. I would end up over here at a sub 24. And my final answer, or the number in the sequence, was 80. So I'd have a dot up here at 80. So my ordered pair would be a sub 24, comma 80. You're not going to have to graph these, I'm pretty sure, but just so that you get an idea of what it's going to look like. Now, let's say we had another point on here, and we know from our sequence that let's go with a sub 2 is negative 8. So we would say a sub 2, that should come down here. I'm sorry. I have a second point at a sub 2 at negative 8. Okay, if I were to connect those 2 points, what would I get? A line. And that's fitting because the name of our section is arithmetic sequences as linear functions. An arithmetic sequence always makes a line when you graph it. Now, in section 3.4, we talked about direct variation, and direct variation graphs always went through the origin. That is not the case for arithmetic sequences. They might, but they don't have to. So if we look at the graph of an arithmetic sequence, we will get a line. Thus, we can determine that arithmetic sequences are linear functions. N is the independent variable, and a sub n is the dependent variable. D, or the common difference, is known as the slope. Okay, we already knew that we can look at the formula. We said that it was a sub n equals a sub 1 plus n minus 1 times d. all they did here was write it as a function, so they took a sub n and rewrote it as f of n. The reason they put n inside of x is because we're dealing with nth terms, not x's. And then they just said, using the commutative property, I can move this to the back side of this. So they have n minus 1 times d plus a sub 1. The domain of this function is a set of counting numbers. So 1, 2, 3, 4, 5. It does not include 0, and it does not include any negatives. Okay? Remember that domain is what would be on the x values. We're not going to write that in. And range is the set of integers on the line. Now, the numbers in the sequence itself can be negative, but the terms cannot be negative. So you might end up with a sub 1 is negative 16. That's okay. 1 is positive and 16 is negative. All right. That's the end of the notes. You should take a look at your homework, get as much of it done as you can. Use your textbook and your notes to do those problems, and if you have any questions, remember to send me an email.